So students, the problem 1 in assignment 2 for the microprocessor, you have to read the problem very well. You have to understand how the memory is laid out, what are the content of each location or each register, in order to successfully put a design for the problem, okay, and then go to the coding. Don't rush with the coding. So the problem as it reads indicates to you that there is some array in the memory. This array of elements, each the list of elements here in the array of a double word sized variables. Double word size. Okay, so double word means each element of my list is 4 bytes. The BX register is pointing to the offset of the first element in the array. The DX register is pointing to the last element of the array. So if we call this array element number 0, that means here I have array element number, okay, n-1. The total number of elements are n. Agree? So we need to design a very simple small program that actually counts the number of elements in the array. So my program, I have to, this is the description of the problem, the layout of the problem. Okay? Description. I have first to design my program before rushing into the code. So here the code design. The logic that I will apply in steps. What are the steps that I want to do? I have BX, I have DX. Okay? Remember that BX and DX are, if in order to go from one element to the next, I have to increment BX by 4, because each element is 4 elements. Each element is 4 bytes. Okay? So if so that means the first address here, if I call that the first element is at BX, the second element, which is element number 1, at BX plus 4. Then BX plus 8. Then until I reach mean the DX. So the design is first to subtract DX minus BX. This subtraction will give me the number of bytes between BX and DX. Agree? It will give me only the number of bytes between them. So it is the number of bytes for the n elements, or for n-1 elements, for n-1 element, because this last element is not counted yet. Okay? So first subtraction. Remember that I don't want to change either the value of BX or the value of DX. So that means I have to store the minion, which is B, D. طبعا هنا in this subtraction, DX act as the minion, while BX is the subtrahend. The menu should be stored somewhere before I do the subtraction, not to lose the value of dx. Then, after this subtraction, in order to convert the number of bytes to number of elements, I have to divide n minus 1 from step 2 by 4. This will convert the operation from the number that we have, from the number of bytes to the number of elements in the array. Step number 3 is to add 1 to the number that we get in 2. يبقى add 1 to result from 2 to get n. Agree? Make sense? Now, how to perform each of those operations? Now I can go to the code, watching the following, that I don't want to overwrite dx. That means dx should be stored somewhere else before I do the subtraction. Second is the division. Here I am dividing by 4. So there are two methods of division. I can either divide, use the div operation, which means I have to involve ax, okay, and dx in the operation, because I am dividing by 4. Okay, I am dividing a word by 4, so that I have to actually involve ax at least in the operation. And or this is one method, or I can do the division. Since it's division by powers of 2, I can use the shift instruction for the division. Okay, agree? Then next, the last operation is to add 1 to the content, so I will get the answer. Okay, so this is the assembly code. First, I will move dx in cx. Okay, moving dx to cx in order to perform the operation through cx instead of dx. So I don't want to lose the index dx that's pointing to the last element of the array. Then sub cx and bx. This is actually copying in cx. Okay, then the second step is to subtract sub cx comma bx. So this actually will put in cx the value of n minus 1 multiplied by 4. This subtraction. Okay, then I have to either make the division first, or adding 4 to this. Another way, I can add 4 to this to get the n and then make the division. Okay, up to you. Then I have to divide. Instead of divide, I want to shift. So I will shift this unsigned or signed shift. This is unsigned. So I will do a logical shift to the right, cx comma 1. This will divide cx by 2. Will give me n over 2. N minus 1 over 2. And then do another shift for cx and 1. So will give me cx now equals to n minus 1. Finally, increment cx, so which actually cx now equals to n. So I will get the number n that he was looking for in the problem definition. Agree? Okay. So now this is actually, come on, this is assignment to problem number 1. This is the solution. As I mentioned before, this is not the only solution. There are hundreds of solutions for this problem. You can, each of those steps, you can do them in a different ways. Okay. However, mathematically, I need to do this operation mathematically. Okay.